Okay, back again. Now, we're going to go ahead and talk about this thing actually operating, hooking up to the 12-volt battery and everything. So, in previous video, I've described that the power goes up to the MOSFET. The MOSFET runs power out to the double pole, double throw relay. The relay runs a positive jolt down to the wiper motor. Now the wiper motor, as I'll talk about in another video, is a peculiar thing. It's always going to have positive and negative polarity running to it at all times. There is a jumper that you have to set, and that jumper is the park function. So what happens is when you hit it with another positive jolt to the chassis, it will cycle through once. It'll go all the way through once. It'll do one cycle. We'll talk about all that another time. What we're going to actually show right now is the box in motion, the target in motion. So I've got over here my 12-volt battery hooked up next to my cup of coffee. Lovely coffee. Got the power running to the Arduino. Everything's all hooked up. And we're going to go ahead and focus in on, we're going to do this a couple of times it looks like, because I can't get a good view of any one thing. So we'll angle in here. You got your crank on the wiper motor, crank that goes up to the swing arm for the target. Alright, so we'll cycle it through once. Go ahead and give that another one because it's kind of blurry, kind of junky, looks kind of horrible. Kind of horrible. Now you'll notice that it goes up, goes down. Interestingly enough, much the same action for the coin pushers. Everything's just mounted a little bit differently. We got the spring over here. This spring is actually for the target's return. That large target in my first video is actually kind of heavy for this motor. It's just a tiny little wiper motor, guys. So the spring is to help assist the return, to help counterset the weight of the target. That's why the motor strains so much in pushing this thing back. Everything is actually tightened up with a friction tension. So there's no keying, there's no slotting, there's none of that, none. The spring I have attached to the base next to one of the crank arms. That's on the cam. And then it's attached to a piece of angle iron that's attached to the box here. I've relocated the sensor so that, yeah, switch, whatever you want to call it. I had to put a lid on this, and it wasn't just because, you know, I had to put a lid or it's nice to put a lid. It's because when you're out shooting in most places and you got a big mud slope berm, every time a bullet hits that berm, it throws a bunch of junk back, especially if it was raining the day before. So this lid acts as a couple of things. One, it helps keep my components safe from flying debris, because that flying debris could be dirt clods, it could be rocks, it could be golf balls, because they shoot golf balls there. And I don't want any of this getting smashed up by incoming debris. So I put a little corrugated plastic top on it. Future targets may be made out of corrugated plastic just because it'll be lighter. It's lighter than the semi-self-healing USGA targets. So, there it is. Thing of beauty. Get one more look over the top here. Try to. It's only fair. Kind of a bit of an angle. Here we go. About like that. Because of how heavy the target is, that swing arm actually goes back a bit further than that. But Future boxes aren't just going to be made of simple 16 gauge steel, right? 16 gauge, what it says, right? 16, can't read it. Here we go. That's actually, no, that's not it. Anyway, yeah, I used angle iron all the way around it to join it up because it's 4 pieces of 16 gauge plate. And I went with a thin plate because as bad as it would be to shoot this thing and accidentally wreck some of my components, far worse to put a AR-500 plate on it and have that bullet come back. So, just saying, went with thinner metal just because of the fact. Doesn't mean that it wouldn't send a bullet back. However, the deal is, you shouldn't be shooting the damn box anyway. It's all bolted up together. I tried to stay as uniform as possible with bolts and stuff, so there's no guessing, none of that. Lots of angle iron and flat bar used here. A little bit of tubing and threaded rod there in the axle for the target mount, etc. Probably noticed the square tubing badly cut up and bent into shape with a few pieces of angle iron to support it. I don't have a real shop to work with or nothing. I just have to make do with what I can, really caveman it together in here. Otherwise that crud would have been welded. Not much else to explain about all of this, really. It's 12 volts. That's the big thing that we've got going here. So, next video, we'll go ahead and we'll talk a little bit about how the motor's wired up, how the wiper motor is wired up. I mean, I spoke of how it's wired up, but I'll actually show you what it does. You could always jump ahead, find somebody else who knows a little bit more about it, but pretty cut and dried little thing here. It really is, the wiper motor. And the beauty of this setup is that I didn't have to code the return. All I had to do was code in a little jolt to make the wiper motor do what I want it to do. Down and up. That's all I wanted it to do. In the future, I'll probably do some craziness with it. I'll probably give it like a timer or something, or make it run faster with a stronger motor or something crazy like that. I did what I did here, the way I did it, because this is the cheapest way to go so far, as I've been able to find. I did have big plans on using super servos and everything else, and I said, you know, that's crazy. It's getting expensive. This project, like $200 tops, maybe. Most of the stuff was found on Amazon. Hardware like the metal wire, I went to places like Lowe's and Depot for that. Connectors for it, stuff. Anyhow, next video, we're going to go ahead and go over wiring up the motor. Not all the wiper motors are the same. They're different. So many of them. So you just gotta really hit and miss and that sort of thing. Alright, awesomeness.